Imagine stepping into an elevator, pressing a button, and being transported straight into space. It sounds like something out of a sci-fi movie, doesn't it? Yet, the concept of a space elevator has fascinated scientists and engineers worldwide for decades. In this video, we'll explore what it would take to build such a marvelous structure, the mind-boggling challenges we'd face, and finally, whether or not it's even possible. Let's dive into the science behind it. The space elevator relies on the principle of centrifugal force. Picture a satellite in geostationary orbit around 36,000 kilometers above Earth. It would stay fixed relative to the planet's surface as the Earth rotates. This satellite would act as the anchor for a cable stretching all the way down to the surface. The biggest hurdle, however, is the material. The cable, which would need to be over 36,000 kilometers long, must endure immense forces from gravity, centrifugal force, and its own weight. Unfortunately, no material we currently have is strong enough. Researchers are exploring options like carbon nanotubes and graphene, ultralight and incredibly strong materials, but producing them on such a massive scale is far from feasible. Now, imagine we've somehow solved the materials issue. How would we actually construct a space elevator? Here's the step-by-step process. First, we'd need to launch a satellite into geostationary orbit. This satellite would act as the upper anchor for the cable. Achieving this would require an extremely powerful rocket to carry such a large structure into space. Next, from the satellite, a cable would be carefully lowered toward Earth, while another part of the cable extends outward into space to maintain balance between gravitational and centrifugal forces. When the cable reaches Earth's surface, it would need to be securely anchored to a massive structure, ideally located along the equator where centrifugal forces are strongest. Lastly, we'd need to design the transport pods, the elevator cars. These would need to travel safely along the cable over distances of more than 36,000 kilometers. One proposed solution is to use laser-powered systems from Earth to provide energy, eliminating the need for heavy onboard fuel. While this process might sound straightforward, the reality is far more daunting. The challenges are immense, starting with the material. Even carbon nanotubes and graphene, the strongest materials we know, aren't strong enough to withstand the forces involved. Plus, manufacturing a cable of this length and durability is currently impossible. Then there's the issue of Earth's weather. Hurricanes, high winds, and lightning could easily damage or destroy the cable. Beyond Earth, space debris poses another major threat. Millions of tiny fragments of old satellites and space junk are orbiting the Earth. Even a small piece could puncture or sever the cable. And let's not forget the cost. Building a space elevator could run into the hundreds of trillions of dollars, an amount far beyond the budget of any single nation or organization. So, is it possible to build a space elevator? With our current technology and materials, the answer is no. The technical, environmental, and financial challenges make this idea nearly impossible to achieve. But that doesn't mean we should stop dreaming. History has shown that the most seemingly absurd ideas often pave the way for humanity's greatest advancements. Perhaps someday, we'll unlock the secrets needed to make this dream a reality. Until then, let's keep pushing the boundaries of what we can achieve. Dream big, because sometimes the most outlandish dreams are the ones that guide humanity forward.